This is the real foldable for 7.3. The last one was actually not the correct section. Hopefully we can figure this out. Anyways, what you're doing today is you're going to fold this one this way, right over here. And what we have is that from last time we were able to tell that some certain things were always true. One of the things that I mentioned is that if we have two angles that are congruent, then we have to know the third is congruent. Saying that having two angles that are congruent, that is enough to say that the two triangles are also congruent. So we're going to make like this. For example, if A is equal to E and A is congruent to D, that's enough to say that these two triangles are congruent. How we would make the similarity statement is we say triangle A, B, C. So the order of the first one really doesn't matter how you write it, but it's going to be similar to the triangle. And since we started with this one, that means it has to be D. And then we went to B, that means it has to be E. And C would correspond with F. The other way that we know that two triangles can be similar is by side, side, side. This time, the sides are not going to be equal to each other. They're proportional. So I'm going to write the similarity statement first. So the triangle ABC. And I'm going to say that it's similar to the triangle DEF. And what this says is that the pair of sides are going to be similar. Proportional. So AB. AB is the first two letters of this triangle right here. AB. That means that they're going to correspond with the DE. So AB corresponds with DE. All right. When you were doing your homework in section 7.2 and you were proving that things were similar, we had to write the ratio. How you prove that the ratio is equal is just make sure you put it in your calculator and simplify it. So, for example, if you put a fraction like 6 divided by 3, that gives you 2, and all of that ratio should be 2 for all of them. Anyways, so let me try to explain it again. So now we have BC, and BC will correspond with the last two letters, EF. That means BC corresponds with the side EF. And these two ratios would have to be the same for this to be true, that they're similar. And then the last one, I have AC, and that's got to correspond with DF. So when you simplify those ratios, they would have to be the same to be by side, side, side. Similarity. And how you usually write it is by the side, side, side like this, just like we did it with congruent. But we have to write the similarity statement, which is that little wiggly line. We had a theorem also that said side, angle, side. And what we're talking about here is that two sides have to be proportional with a congruent angle. So let me write the similarity statement first. So I'm going to have triangle ABC is similar to triangle, and I'm going to say DEF. And what this theorem wants is that if I say A and DE are the ones that correspond with one another, and we write that ratio, AB corresponds with DE. And we also had that BC and EF are the sides that correspond with one another. BC and EF. If those two fractions simplify to be the same number, that means that the ratio, the scale factor is the same, and that the angle between them, that would be this one and this one, is given, so angle B is congruent, because remember, angles have to be equal to one another, then we have enough to say that these two triangles were similar. So let me say it again. We have a pair of sides that sandwich that angle in the middle to give you side, angle, side. The ratio of this one and the ratio of this one have to be equal, and the angle between them has to be congruent. Okay, so let's take a look inside. And what we're trying to do is prove, can we prove that these two triangles are congruent? So I have these two and these two. That's enough to say that the triangle ABC is similar to the triangle DEF by angle, angle, similarity. You can write the symbol, you can write the word. Then when you have that, so how can we prove that these two are equal to each other? I'm going to separate them real quick. You have a big triangle right here. And that angle I is true on both. And look at this little triangle right here. So I'm going to draw it over here, the little one. So I is the same on both. And because they're parallel line, corresponding angles are also equal. So that means this is equal to this. Two angles is enough to say that the two triangles are similar, the big one and then the small one that's on the inside. And now we can set up the proportion. So x corresponds with the whole side, x plus 6, because that's the whole side of that triangle. So I'm going to say it again. We have x is this side right here, and corresponds with that big triangle, x plus 6. And then what looks like the top of the little triangle, 8, and the top of the big triangle, 12. From here we cross multiply and solve for x. I'm going to skip this one just because I think you know how to do it, but I will do the next one because it's just a little bit more complicated. Alright, so here, don't forget that we have vertical angles are congruent. We don't have to be told, this is just implied. We also got parallel lines, so we have alternate interior angles are congruent. That's enough to say that these two triangles are congruent. I mean similar. They're similar. Once we know that they're similar, we can set up the proportion. I will look at the sides that are parallel, so I'm going to do 3 divided by 5. And then this side corresponds with this side. I'm going to write this one first because I wrote the 3 first. X plus 1 and x minus 2. Alright, so let's do this one. We're going to have this right here. That would give you 3 open parentheses x minus 2 is equal to 5. And we're multiplying by the whole thing, so we got to put open parentheses x plus 1. You're going to do the distributive property. 3x minus 6 is equal to 5x plus 5. 3 times x, 3x. 3 times a negative 2, a negative 6. 5 times x, 5x. 5 times 1, 5. I go ahead and I subtract the 5x from both sides. I go ahead and add the 6 to both sides as well. I have negative 2x is equal to 11. I'm going to divide by negative 2 to both sides. X is equal to a negative 11 halves, or if you want to write the decimal approximation. So angle, angled. 2 angles is enough to tell you that the two triangles will be similar. Remember, this one was side, side, side proportionality. So we got to know if they're proportional or not. On section 7.2, this is what I expected. So if you didn't get that done, we got to fix it. I'm going to compare the smallest side with the smallest side, because that's the only way that it should work. So 6 is the smallest side, and then 12. So I'm going to say 6 divided by 12. That's going to give you 0.5. All right, so far so good. And then we're going to compare the middle sides. The middle would be 7 and then 14. So 7 divided by 14. When you simplify that fraction, it gives you 0.5. All right. Then the last one is the biggest side, which is equal to 8 divided by 16. So all the ratios end up being the same as 0.5. That means that these two triangles are similar. So we write that the triangle ABC is similar to triangle DEF by side, side, side similarity. Okay, so how did I know that AB corresponded with DE? Remember, it was the smallest side compared to the smallest side. And this should be able to remind you of how those letters went together. So you do have to check. You have to check that all of these sides are proportional. Once you know that, then it'll help you out figure out the rest. So let's make sure. And we got the smallest side, and we're going to compare it to the smallest side. So we got 6 divided by 4. And is that equal to 9 divided by 6? How did I get that? Well, this is the biggest number, and I compared it to the biggest number on this triangle. Then the last one is that I got the smallest compared to the smallest. So I would have to write this one first, because that's how I've been doing the rest, divided by 5. They happen to be all equal the same. How do you tell? Just put it in your calculator and get that decimal approximation. So now I need to figure out what x equals. I know this one has to be 40. Okay, so x cannot equal 40. And then this is 80. And since I have these two right there, and these two right here, that means that this one's the one that corresponds. This angle corresponds here. Let me say that again. The sides matter. See, one's on the right and one's on the left of this angle. That's why this one has to be 80. So what's the angle that's missing? We do 180 minus 40 minus 80, and that's going to give you 60. That means x is equal to 60. Because this one is 60 right here, that means that this one has to be 60. So it kind of works off of this one right here. Once you know that two angles are congruent, then the third has to be equal to the other angle that's missing. All right. So we could solve for x, or we could just determine whether they are proportional or not. Let's try this again. The smallest side with the smallest side, 5/10 is equal to 0.5. They don't always equal 0.5. That's just what ended up happening. And then the middle side with the middle one, 12 divided by 24, it's still equal to 0.5. We're doing great. And then the biggest side with the biggest side, 13 divided by 26. And that's equal to 0.5. So that's great. The proportion is set correctly. That means that we do have that the triangle RQS is similar to the triangle. So if I started with R, that means I have to do T. Q would have to be S, and then U. And you say by side, side, side similarity. Alright, the last one. We're proving whether these two triangles are similar, and we have to compare the sides. I have the smallest side with the smallest side. 6 divided by 15. And then you have to do the biggest side with the biggest side. They have to be equal. So if you don't know whether these simplify to be equal fractions or not, just put it in the calculator and that decimal will tell you. So these two sides are proportional and they have an included angle between them. So I can say that the triangle ABC is similar to the triangle DEF by side angle side similarity. So we got a pair of sides and the angle between them. Okay, so then we have this one right here. We need this one. This was the smallest one, and this one would be the smallest one. 5/5, sorry. I always try to let you write it from left to right. So this one's first, 5/4. So is that equal to 6/5? Put it in the calculator. Are they equal? No, they're not equal. So this is not similar. Once you know that something is not similar, then you cannot write a similarity statement. They're not similar, so you can't write it. Okay, and then our last one. So don't forget these are vertical angles. That means this is 40. If you're not told whether the triangles are similar or not, then you have to figure it out. Are they? Let's figure it out. We have 15 is the smallest, and we're going to compare it to the 5. So 15 divided by 5. And then I'm going to do 21 divided by 7. So if you don't have a calculator handy, you might just want to simplify these fractions. Well, 15 divided by 5 is 3, and so is 21 divided by 7 is 3. Woohoo! So that means it is proportional, and they have an included angle. That means that this is proportional by side angle side similarity. And we can solve for x. I'm going to write it this way just because that's what we were used to. I have 15 divided by 5 is equal to x divided by 4. Sorry, let me make a squiggle just to make sure that you're okay. That's 60. 60 is equal to 5x. Then we're going to divide by 5. 12 is equal to x. Yes, you could have written 3 right here. You would just say 3 times 4 and gotten the same answer. But since we've been doing proportions for the rest of the assignment, then that's what we did here. Alright, so please don't forget to tell me if they are similar by what, so yes or no. And then if they are similar, you can write a similarity statement. So I think you should be okay with all of these. And then I'm looking just for one answer on problems 5 and 6. Make sure that you try to catch up with all your homework. Get it done, please. I'm going to have someone pick it up for me, and I'm going to be grading that, so make sure that it gets all done. Please let me know if you have any questions.